So, as another interesting example of complicated things you can do with Spark that you might not have thought you could do with Spark, let's talk about item-based collaborative filtering. This is basically a recommender engine algorithm. It's the way that Amazon used to do things like people who bought this also bought, or recommend things to you based on your past purchases. The high-level idea is that we can take a look at the stuff that you've bought in the past, look for similar items to the stuff that you bought, and then recommend those items to you as things you might be interested in. And we're going to do this in the context of movies using the Movie Lens dataset. So the fundamental thing we need is some measurement of movies that are similar to each other based on user ratings. So that's what we're going to do here. And while we're at it, we're also going to introduce the concept of caching your datasets to improve performance. So similar movies. This is a little screenshot, an older one from the Group Lens website. So they actually have a UI where you can rate movies, tell them explicitly the movies that you've liked, and it will recommend new movies to you based on those ratings. So one way to do it is to take a look at all the movies that you've liked, and for all of those movies, look at the similar movies to those movies. And those similarities will be based on other users who like the same movies that you liked. Okay? So the basic algorithm here is that we're going to start by finding every pair of movies that were watched by the same person. Our objective here is to find all the movies that are similar to every other movie. Okay? To do that, we're going to first break down every pair of movies that were watched by the same persons. So if user A and user B both watched the same movie and liked it, that would be a pair of movies. Now we can then take together all the users that like those pairs of movies and measure the similarity of their ratings across all of them who watched both of those movies. So based on every user who watched that pair of movies and liked it, how similar are those movies in terms of ratings? Then we can group those all together by the movie ID, sort them based on their similarity strength. That's something that we compute based on those ratings. And then we have a sorted list of movies that are similar to every other movie just by that simple algorithm. So this is just one way to do it, mind you. There are many other techniques out there as well, but this one's simple, and sometimes simple is better, and it produces good results if you have enough data. Let me walk you through the algorithm in more of a graphical manner here. So imagine that Anne here watched both Star Wars and The Empire Strikes Back, which is the sequel to Star Wars, and she liked them both. And then Bob here, the guy with the mohawk, also watched Star Wars and The Empire Strikes Back and liked them both as well. So based on this information, we can say that we have a pair of movies here, Star Wars and The Empire Strikes Back. And they both have these two users in common who both like them. So for that pair, we know that user Anne and user Bob both like them, and let's imagine they both gave them 5 stars. So based on that, we can compute that these are very similar movies based on that user rating behavior. Of the 3 people in our data set, 2 of them both loved this pair of movies, right? So that would yield a very good similarity score, however we might choose to measure that. Now let's imagine Ted here at the bottom comes along, and he only watched The Empire Strikes Back. Maybe he just moved here and came from a country where Star Wars isn't a big thing. That's okay. But somehow he doesn't know that the first movie, Star Wars: A New Hope, actually existed. So how do we recommend to him what else he might be interested in watching based on the information that we have here? Well, we could say, okay, we know, Ted, you liked Empire Strikes Back, and we know from our previous computation that the most similar movie to Empire Strikes Back is Star Wars: A New Hope, the first movie. And again, that similarity was based on the rating behavior of the other users in our data set. So that's it at a high level. Basically, we can recommend movies that are similar to the movies that you've loved based on the rating behavior of the other people in our data set. And that's item-based collaborative filtering in a nutshell. So ultimately, that recommends a good movie to Ted that he maybe didn't know about before. Now, we're going to focus here in this activity on just the movie similarity portion of it. So we're not going to actually be doing full-blown recommendations for people, but we are going to be computing that data set of movie similarities. What movies are similar to other movies based on user behavior? That's kind of the hard part, right? Because once you have that data, you can make recommendations to people very quickly based on the stuff that they've liked before. So you might say to yourself, how the heck can we do this in Spark? I mean, Spark is kind of built around a SQL paradigm these days, or maybe a MapReduce at best. How do you frame this as a problem that fits into that framework and something you can parallelize? Well, you can. You just have to think about it creatively. And again, being able to think about these problems in a creative manner is what they pay you the big bucks for. So it's an example of how you can use this technology to solve a problem you might not have thought it was suited for. Here's the general algorithm that we're going to use in our Spark example. So we'll start by selecting the user IDs, movie IDs, and ratings. In this example, we don't really care about the times, although you could imagine a world where you use that information as well. We then find every movie pair that was rated by the same user. And that might sound like a tricky thing to do, but it turns out with a self-join operation, which is very much a database kind of thing to do, that's exactly what it will give you. Basically, you take the set of user, movie, and rating columns and join that on itself based on the user ID, and that will give you every possible pair of movies that were rated by the same person. So at that point, we can reframe our self-joined dataset to have movie 1, movie 2, rating 1, and rating 2 columns that will tell us the movie pairs and the ratings associated with each. And again, at this point, this will be done for every unique user who rated those two movies together. We can then go through and filter out, while we're at it, any duplicate pairs, because a rating of movie 1 to movie 2 is the same thing as movie 2 to movie 1. So we'll have some heuristic in there to make sure that we only capture one of those two variations. Once we have that, we can go through every user that rated that pair of movies and compute the cosine similarity score based on that information. I don't want to get into the math of that because it's not really relevant to Apache Spark development, but if you're curious about how cosine similarity works, there's another course that I have on recommender systems that gets into more depth on it. But at a high level, if you take a look at all the user ratings for a movie, you can think of that as sort of a multi-dimensional vector. And a cosine similarity score would basically be the angle between two vectors for two different movies based on the user ratings that they have in common. So once we have that, we can group everything by the movie 1, movie 2 pairs and make sure that we aggregate everything together for a given movie pair, computing that cosine similarity across all the users who rated that pair of movies. So at this point, we have a data set that contains every possible pairing of movies and the similarity score between those pairs of movies. We can then just filter and sort and display the results. So we can group those together by each individual movie ID, filter out things that are below some sort of similarity score threshold to make sure that we're only capturing strong similarities, and sort them by that similarity score and display the final results. And that will ultimately give us the similarity score from any given movie to any other movie. So before we dive into the code, let me introduce the idea of caching data sets, because this is going to come up in this example. Oftentimes when you're doing complicated things like this, you end up querying or using a data set more than once. And if you find yourself doing that, you should explicitly cache it if you can. Otherwise, there's a chance that Spark might end up reevaluating that entire data set all over again a second time just to do that second operation on it. And if you want to make sure that that doesn't happen, you can use .cache on a data set after you're done computing it to make sure that it sticks around in memory, so any subsequent operations or analysis that you do on that data set happens as quickly as possible. There's also .persist. Persist will optionally let you cache that not just to memory, but also to disk. So if a node fails or something, you can recover from that point and just pick up where you left off. So cache will be in memory. Persist can optionally be persisted to disk as well. And with that, let's jump off to the code and see what it looks like.